Alright, so hi class. For our today lessons, we are going to look at the last subtopic of chapter 1, which is stoichiometry. So the learning outcomes over here. First, we need to know how to write and balance chemical reactions by using inspections method, and also to balance redox equation by using ion-electron method. Next, we want to define limiting reactant and percentage yield so that we can perform stoichiometry calculations by using mole concept, including limiting reactant and percentage yield. So first of all, let's look at the balancing equation using inspection method. Inspections methods over here means the normal way we want to balance a chemical equation. But over here, method I give you several steps to give you a guideline on how to start balancing an equation. So step 1, write the chemical equation using correct chemical formula for all species. So of course you need to know for magnesium, the symbol is Mg. For oxygens, the element, we will write as O2. And then magnesium oxide MgO, because magnesium it comes with the oxidation or the charge with positive 2, and the oxygen is negative 2. Okay, so this is just the species. Then steps 2, you need to balance the atom. Always start with the most complex substance and deal with one element at one time. Okay, and then we want to balance the magnesium and oxygens on the left. Last step is by adjusting the coefficients. We will prefer a smallest whole number coefficients for all of this. So if you look at the first examples over here, we want to balance magnesium. So see, it's very clearly we have 1 mg on the left. Okay, so we put 1 magnesium oxide on our right hand side. So if you can see over here, 1 mg, they are balanced, then we want to balance the oxygen. Since you only have 1 oxygen on the right, and then on the left, we need to halve the O2 so that they can balance to become 1 oxygen on the left, 1 oxygen on the right. So if you follow the steps over here, you can clearly see that you will eventually get the answer at the end. Okay, so we will prefer the smallest whole number. Because we have a fractions over here, you just need to times every species by the value of 2 to get 2 magnesium, 1 mole of O2, and then 2 mole of magnesium oxide. Okay, so this is the normal way that you use to balance an equation. Okay, so the next method using for balancing chemical equation, or most commonly known as to balance a redox equation, okay, is called the ion-electron method. Okay, so redox reactions, it means you will have two process. You will have a reduction reaction and also oxidation reaction. So oxidations, it means the oxidation number increases, and reduction, it means the oxidation number will decrease. So looking at the example given here, we get Fe2 plus MnO4 minus to produce Fe3 plus and also Mn2 plus. So during the case like this, first of all, you need to pair up the same species. Okay, the meaning of pair up the same species is Fe, you pair up with Fe. Okay, and NO4 you pair up as long as you can see this manganese. Okay, so if the oxidation number increases, therefore it refers to oxidation. If the oxidation number decreases, it refers to reductions. So obviously, if you can see over here, Fe2 plus increases the oxidation number from 2 plus into 3 plus. So this process is the oxidation. But that one is simple because you only got a single and a very simple ion. But what if you have a compound ion which look like this, MnO4 minus and also Mn2 plus. So this Mn2 plus, the oxidation number is the same as the overall charge. So we have a plus 2 over here. Okay, so you need to understand and you need to be able to calculate the oxidation number for the manganese, Mn. Okay, so the points over here, madam have already put down. Oxidation number of a single ion is the same as the overall charge. So for example, for Fe2 plus, Fe3 plus. So very straightforward. Okay, but for a complex ion such as MnO4 minus, you need to calculate the oxidation number of this Mn ion to see whether the oxidation number is increased or decreased. So the ways of finding the oxidation number is very easy. So we just put Mn as the unknown plus 4 molecules or 4 atoms of oxygen. So 4 times with the oxidation number of oxygen equals to the overall charge of -1. So if you look at the complex ion MnO4 minus, this -1, refer to the whole complex. Okay, so this is the charge for the whole complex. So we just put it like this. Manganese plus 4 times -2. -2 is the oxidation number of oxygen. Okay, equals to the overall charge, which is -1. So you do a simple mathematics and you will find the manganese oxidation numbers is equals to +7. Remember to put in the sign. Okay, because we have a positive sign and also negative sign. So the sign is very important. Okay, so now after you have found the value, so we can see the manganese, +7, has been reduced to +2. Therefore, this process, this pair of species undergo reduction. So next, we want to know the steps in balancing our redox equation. So there is 2 medium that you need to take notes. If the question is asking in acidic medium, therefore it will be from step 1 until step 6. Okay, if it's asking for basic medium, therefore you're required to write all the way from step 1 until step 8. So I differentiate into different colors. The middle one, step 2 until step 5, is for both half equation. So let's look at step 1 first. Step 1, you need to separate the unbalanced equation into 2 half equation. That's why we need to know about reduction and oxidation reactions earlier. Okay, so after you have separate into 2 half equation, so step 2, 3, 4, and 5 is for both. So you need to do it 2 times for the oxidation as well as for reduction. So for our step 2, balance the element other than oxygen and hydrogen. Step 3, add H2O to balance oxygen atom. So let's say you have 2 oxygen atom, you need to add 2 mole of H2O. Step 4, add H plus to balance hydrogen atom. So for example, if you have 8 hydrogen atoms, then you need to add 8 hydrogen H plus. Step 5, add electron to balance the charge on both sides, so that the overall charge on the left and on the right are equal. After we have done step 2 until step 5, then step 6 will be adding both of the half equation. So step 1 until step 6 is in acidic medium. Then step 7 and 8 is an extra if you require to answer the balancing equation in basic medium. So step 7, continue from step 1 until step 6. Step 7, basic medium, we need to add OH minus for both sides of the equation for every single H plus. Step 8, H plus OH minus equals to 1 mole of H2O. So we need to simplify the number of H2O for the overall equation. So always refer back to this table when you are doing a balancing equation for redox equation. Alright, so let's try this example. So just now we have already identified the oxidation's half equations, which is from Fe2 plus into Fe3 plus, because the oxidation number increased, and for reductions, because the manganese is +7 reduced to +2, so it is undergoing reduction. So we classify into 2 half equation, which is our step 1. Okay, so step 2 in each half equation, we need to do checking for step 2 until step 5. So let's look at the simple one. For our oxidation process, the Fe is already balanced. It doesn't have oxygen, it doesn't have hydrogen. So straight away we go to step 5. Okay, so to balance the charge for both sides, if you can look at here, on our left hand side is +2, on our right hand side is +3. So to balance the charge, we need to add electrons. Okay, step 5, add electron. So always adding electrons to the side which has a higher overall charge. So in this case, on our right hand side, you have positive 3 is higher. Then we will add one more electrons on the right hand side. So the overall equation here, when you add one more electron, that means you add a -1. Okay, so the overall charge on the left and also on the right become balanced. So we have done for oxidation part. Whereas for our reduction, so let's look at step 2 again. So step 2, balance the element other than oxygens and hydrogen. So our Mn is already balanced. Left we got 1, right also have 1. So we proceed to step 3. Add H2O to balance oxygen atom. So if you look at here, on our left hand side we have 4 oxygen. Okay, this MnO4 we have 4 oxygen. So on our right we need to add 4 more oxygen. So how? By adding 4 H2O molecule. Okay, so I repeat now. Manganese Mn is already balanced. Then we look to the oxygens. By balancing oxygens, we need to add H2O. So 4 oxygens on the left and 4 oxygens on the right. So after you have done step 3, then proceed to step 4. So on our step 4, we need to balance hydrogen atom. So now look at this one. Our right hand side, okay, altogether we have 8 hydrogen. So on our left hand side, you need to add 8 H plus. Okay, so I repeat now, the one in blue color. Because of this 8 hydrogen on our right, we need to add another 8 H plus on the left. Okay, so step 2, Mn are balanced. Step 3, oxygens are balanced. Step 4, hydrogens are balanced. So we need to do our step 5. So let's look a little bit on the overall charge on the left and also on the right. So looking at the charge, positive 8, okay, -1. So the overall charge on our left hand side is positive 7. On the right hand side, we have a positive 2, H2O, no overall charge. So on our right hand side, you have a positive 2. So always add electron to the side which has a higher value. So we want to balance the positive 7 until positive 2. Therefore, we need to add 5 more electrons. Okay, you need to add 5 more electrons. So we calculate again. 5 electrons, that means we have -5. We plus 8, which is from our H plus. We -1, which is from our MnO4 minus. In this case, we have already balanced our overall charge, okay, on the left equals to the right hand side. Positive 2, positive 2. So we have done also for our reduction equation. Okay, so step 2 done for both. Step 3, step 4, step 5. So now we come back to our step 6. So step 6, you need to add 2 half equation. Okay, when you want to add 2 of this half equation, you need to make sure this number of electrons are equal so they can cancel each other. Okay, so how are we going to do it? You see, reduction equation, we have 5 electrons. We need to times the oxidation equations by a value of 5. Therefore, we have 5 Fe2 plus, okay, 5 Fe3 plus another 5 electron. For reduction side, no problem. We just copy back exactly the same thing from our balanced half equation just now. Okay, plus MnO4 minus into Mn2 plus and also 4H2O. So now you can see over here on our left 5 electron, right 5 electron. So when you want to add up both of these equations, you can simply cancel off. Okay, the criteria for us to cancel off each other for both half equation, one must be on the right, another will be on the left, so you can cancel. If they are on the same side, then we will add up together. Okay, so for this case, nothing else we can simplify, nothing else we can cancel. Then you just need to recopy back the whole things. So it becomes 5Fe2 plus and 4H2O. So just do a little bit of last checking. For this one, if you want to see whether it is in an acidic medium or basic medium, you look at the overall equation. I can see. Over here, I can see 8H+. And we know that acidic medium, H+ is present. So that means the whole things over here is present inside the acidic medium. So we have done until step 6, which is referred to acidic medium. If you want to do for basic medium, yes, no problem. Do it all over again from step 1, and then we just add another 2 more steps, which is step 7 and step 8. Okay, so in basic medium, we need to add 2 more extra steps, your step 7 and also step 8. So look at the number of H plus in the final equation just now we have got. Okay, just now we have 8H plus. So on the left, we need to add another 8 molecule of OH minus. On our right as well, we need to add another 8 OH minus. So for basic medium, step number 7, 8 the number of OH minus according to the number of H plus to both sides of your equation. And then after that, we need to simplify. So you look at this one, 8 OH minus, 8 H plus. Adding up both of these will give you 8 molecule of H2O. Okay, and then you look at the right hand side. Here already have 4 molecule of water. So we need to simplify to make it only one species. Then we can bring the 4H2O to the left hand side. So in other words, we can simplify 8 minus 4, you left with 4. So this one is after we have made the H2O molecule, we can cancel off first to avoid confusion. So now on our left hand side, you remains with 4 molecule of H2O, 5 molecule of Fe2+, 1 MnO4 minus. So you can recopy down the statement here, the balance equation, 4H2O, 5 Fe2+, MnO4 minus on the right, on the left, and on the right we have 5 Fe3+, 1 Mn2+, and also 8 OH minus. So final checking, in basic medium, there is a presence of OH minus. So until here is the equation, the balance equation in our basic medium.